Cool. So yesterday what we have seen is we have seen the introduction to Spark. So that is the Spark definition we have seen. Then afterwards we have tried to understand the Spark architecture. Then how the internal execution or the runtime architecture of Spark is when a user or a client submits an application code to the cluster or to the driver program. That's what we have seen, right? Then we try to understand the Spark ecosystem. What does it comprises of? Okay, so we try to understand that. So after understanding that, we made a move to write a small word count program in 3 environments like REPL and Jupyter, which we have seen. And today we'll try to demonstrate the same thing in PyCharm. Okay, cool. Before that, I needed to show one thing, because if you remember yesterday when we were trying to configure we were trying to configure the project in PyCharm. Okay, cool. So what we are trying to learn, we are here to learn big data with AWS. Okay, that's what good we are here to learn. But again, in Spark, we are not learning Scala Spark, but we are learning PySpark. So if you remember, we have studied Python and now we have started with Spark. So the combination of this is making PySpark. Okay. So we need to understand PySpark. So PySpark is a Python API. Okay. So if you remember yesterday, Spark ecosystem, it has 2 layers. So the first layer is Spark core, which is nothing but your RDDs, and RDDs are nothing but your low level APIs which can be written in 4 different programming languages. So Python. So using Python API, okay, so PySpark can be written. So PySpark is a Python API for Spark. Why? To process large data sets. And that's where the power of Spark comes, because it has the more power to process large data sets because it has a distributed platform processing framework. Okay, so that's why Spark can process large data set, and that's where we are learning PySpark, and it has a Python API in your Spark ecosystem. So in a distributed cluster. Okay, so PySpark is a Python API for Spark to process large data sets in a distributed cluster. As we know, or might not be knowing, now you might be knowing, so that is Spark is written in Scala. Okay, and Scala is interoperable with Java. What does interoperable means over here is, just wait a minute. Okay, sorry for that. Okay, so Spark is written in Scala. Okay, so Scala is interoperable with Java. So interoperable means is, okay, I can write Java, I can use Java libraries in Scala, or I can use Scala libraries in Java. That's why like they are having a very good handshake. So when it comes to PySpark, we need to have a handshake, or we need to have these two people's capabilities. How can I have that capability? Okay, so there is a person, and that person is nothing but Py4j library. If you remember yesterday when I was trying to configure my PyCharm, I was trying to install this module that was Py4j or package. So Py4j, what it is a Java library. Py4j is a Java library that is integrated within PySpark. Okay, which allows Python to dynamically interface with JVM objects. Now what does JVM means? If you know like the concept of like when core Java, when it is coming from, okay, so if you submit, there is a class loader, Java virtual machine, so all this, so we need to get this JVM because everything is a JVM. So if you talk about this architecture, okay, so the driver program is internally like one of the JVM. So this worker node is one of the JVM, the worker node this, and so on. So that's why we need a package, and that package name is Py4j. So it's a Java library that is integrated with PySpark, which allows Python to dynamically interface with JVM objects. Okay, which will allow us to run PySpark. So that's why if you want to practice PySpark, okay, you need Java in your machine, you need Python in your machine, and you need Spark in your machine. Okay, so Py4j is an important Java library that is integrated with PySpark, which allows Python to dynamically interface with JVM objects. That's why if you talk about Spark Scala, this is not needed. Why? Because that is interoperable with Java, but Python is not interoperable. So with this Py4j library, it can have its JVM objects and interact. So that's why we need to have this. Okay, so this was like important point which I missed to tell yesterday, and that's where like I have tried to recall. Now we will try to configure the PyCharm again. Okay, so yesterday we have seen, but again we'll try to see the 4 steps what we were trying to do yesterday. So this is my virtual machine which I have handed over to you. You know the credentials which are being shared. Okay, so you just need to clear off the screen and you need to start your Hadoop services. Okay, so meanwhile I will just click on this PyCharm. My PyCharm will be up and running. Okay, so it will consume a little time because it will take a little time. So let it take time and let it come. So meanwhile it is coming, what we will do is we will just let's wait for each command to get executed. So if you see, this is completed, and then we'll try to go with start-.ynn, that is such. So this will start all my Hadoop daemons which are required. Okay, and meanwhile my PyCharm will also be up and running, and we'll try to execute, or we'll try to write the same word count program which we were writing yesterday in PyCharm by configuring the project again. Okay, so there were 4 steps involved. Okay, so the first step is nothing but we need to create a project. Okay, what is the first step? The first step is we need to create a project. How we will create a project? Let's see those steps step by step and understand, and then we can do it. Okay, and it's like a one-time configuration you would be doing. So what we will do, we will close this for the time being. So if you open your PyCharm for the first time, this will look like this, and for you it will not be available. For me it is available. So what you will say, can you see this new project? So you just need to click on this, and you need to give the name of the project. So let's say I'm just trying to give, let's say, testing. It's your call. You can give any name of your choice. I'm just trying to give testing for me, and you will say create. So what is the first step? Create a project. That is your first step. Then once all the necessary updates will happen, let it happen. So the second step, what you need to do is you need to click on file. You need to go to the settings tab. Okay, okay, so what is the second step? So you need to go to the file and you need to go to the settings tab. In that, whatever project which you have created, okay, you need to expand that. Okay, after expanding, you need to click on the first one, Python interpreter. Okay, so here you need to provide by navigating through that Python package. So what is the second step you will do? Second step is click on file. Okay, click on file, then settings tab. Okay, then under your project, okay, so you will click on Python interpreter. That's what we have done, right? So you need to click on this plus icon. Okay, and here if you see in this project, I do not have any packages. So first, I will try to install my PySpark. So the latest version is 3.1.2, but we will be going with one specific version, that is 3.0.1, which is being tested by me, because moving ahead we will be seeing lot many integrations. From PySpark, we will be trying to integrate databases, MySQL, Kafka, structured streaming, AWS, NoSQL databases, and so on. So there should not be any issues. Okay. So what you will do, you will type PySpark, click on the specific version, and you will say install package. Based on your internet
Seth,
connectivity, let me finish.
Seth,
Yeah,
yeah,
let me finish. I'll take your question.
okay.
So based on your internet connectivity or whatever your speed is, it will try to install this package and you will get to know. Yeah, you can ask. Yeah, tell me.
Yeah, I can see the PySpark, but there's no version associated with it. I can see the plain list.
Here at the bottom, you're not able to see.
Yeah, see, you have this PySpark, and in the list you have this PySpark, and along with there's some URL, correct? So this is not available.
It's okay. At the bottom, are you able to see this 3.0.1?
So I have 3.1.2.
Okay, once you do that, you just need to close this. Okay, see, this is the Py4j library which we just had a talk about. So this is a Java library which is required to allow your PySpark programs. Why? Because Python needs to be having a JVM object. That's why. Okay. So this Py4j library and PySpark package is installed. So first step is done. Second step, what you'll have to do is, okay, so here what you need to do is you need to install PySpark, and that version is 3.0.1. Okay. So the third step, you need to follow the same process. You need to navigate till here, but in place of Python interpreter, there is a second or a tab below that, that is Python structure. So you need to click on that, Python structure. Okay, and then here you need to say add contents. And if you remember yesterday, or even if you don't remember, so you need to navigate through a path, and that path is USR. Under USR, there is a local folder. Under local folder or a terms of directory in Unix, there is a folder called Hadoop env. Then we have Spark, and under Spark we have Python. So we need to navigate till here, and we just need to say OK. So we are assigning Python, so we can write Python code. Similarly, if I want to write my PySpark, so we need to have a Py4j library. So the second step in the same process, we need to go again, add content root, same path. You just need to expand Python, and under lib directory you will be having, so let me copy this till lib so you can have this as well. Okay, so under library you have this PySpark and Py4j, and you need to say OK. And just scroll a little down. If you want to say apply, OK, you can follow both the things. So these are the three steps which you will have to perform. So the first step is create a project. Okay, name the project as per you. After naming the project, the second step is you need to install PySpark. The third step is you need to assign Python. The fourth step is you need to assign Py4j and PySpark lib files to your project, so that we can write PySpark program, and internally they can have JVM objects which could allow us to run PySpark. So are we good in these three steps? I hope like we should be able to create our structure or project structure. Yes or no?
Yes, sir.
Okay. So after that, what you need to do is, if you see this project name, you just need to expand this. And if you see the first, that is first folder name or the directory name, that is testing, you just need to say right click, you just need to say new, and you just need to say Python file. Name of your Python file. So I'm saying this is word count and the extension would be .py. Okay, as of now we'll not do unit testing. I'll show you a little later, because for that we need to install PyTest library package. Okay, so word count.py. So now there, if you see, there is an interface which is blank. Here I will be writing all my codes and I would be achieving whatever the requirement is based on the PySpark. So if you remember yesterday, to create a program in your IDEs, we need some objects, right? So what were the objects which we were needing? We were needing like Spark context and Spark session, right? So this is like, I'll show you with Spark context, Spark session, and maybe like next week we'll see the newer version, that is Spark session. Okay. So for the first step will be, you'll have to import from PySpark. You will have to import. What you'll have to import? I'll have to import Spark context. From PySpark, you will have to import Spark conf. What I can do is, I can just separate this and I can write Spark conf here also. In one statement, I can write here also. It's your call how you write. Try to write in separate lines so that you will get a knack of writing and you will understand and you will remember these packages. Okay, this package is required for this, that is required for that, this function is required for this library is required for that, that module is required for that. That's why I will be showing everything and we will follow that practice. But if you go to projects, you might find star over here. Okay, import everything. But we'll go with everything. Okay. So we imported couple of packages from PySpark, okay, or couple of classes to be precise from that PySpark package. Now I'm trying to create a main. Okay, just type main and hit an enter. Don't worry, I will tell you the meaning of this at a later stage, as this is very early. Okay, what does underscore underscore double underscore means, like strong privates, all those things will come later. As of now, we are not worried about it. Now the first step is over here, what I'm trying to do is, I'm trying to create, we have created a Spark context. So now I will try to do the same thing, that is create Spark context with some configurations, I can say. Okay. So here what you'll have to do is, you'll have to follow the indentation. That's what we have seen in Python, right? When you are writing over here, let me open a new terminal, and when I'm trying to type PySpark, okay, so here also when we are trying to write the code, we were following some indentation when it comes to Python. I should have opened Python 3. Okay, so when, if you remember, like we were trying to define some functions, so we were following the indentation. So we were writing some for loops, we were writing some decision statements, so we were following the indentation. So when it comes to IDE, you don't need to worry about it, because as soon as you put your colon symbol and you hit enter, it will automatically take care of your indentation. But when it comes to an interactive mode, that is REPL, as a developer, you'll have to take care. But we do not write the code over here, because we test the code and we write our final codes over here, either in IDE like Jupyter or PyCharm. So what we need to do is, we need to create a Spark context with Spark conf. So I'll try to create a Spark conf over here. So I'm trying to create this identifier, or we know it's a variable name. Okay, in terms of Python, it's called identifier. So identifier will always start with your lowercase. That's what we have studied in Python, right? So we'll follow the same thing. So in Spark conf, we need to get a class, right? So this is the class which we have imported from this package. Okay, so what I'll do, so when it comes to Spark Scala, we write a new keyword, and from this class we try to create an object. But when it comes to PySpark, we do not have that mechanism over here. So straight away what I will say is, from SparkConf, okay, I need to get all the methods, all the functions, whatever is available. Can you see? As soon as I say dot, all gets highlighted which is available. So I can start making use of it. So I want to have my application name. So let's say the application name is nothing but word count program. Okay. After that, I will try to set my master. Okay, don't worry about this. As of now, I'll not say what does it mean, because maybe at a later stage when the right time comes, I will tell you why I'm writing star, why I'm writing a certain number. Okay, as of now, I'm using all the resources. Okay, so what I've done, I've written few things. Then afterwards, I will try to use Spark context, and I'll try to use this class which I have imported from a library, or from a PySpark package. And here I'll try to pass my SparkConf. So this is how you will be initializing your Spark context, which is nothing but this, in your driver program. So when you execute, or when you write this, so when you execute your program, okay, so now when I'm trying to run this program, what exactly is happening is,
breaking, sir.
so I've just tested this program, okay, whether my configuration is working fine or not. If you see, I'm getting an output testing. So if you remember yesterday, someone asked a question, do I need to write all my collect programs? Yes, if you need to see your output in the console, you will be using some actions. As of now, I have not shown those actions. Maybe like later I will show. Okay. So what we have done, we have initialized our Spark context. So when we execute this program, or this is called the application. So this application will be submitted to where? To your driver program. Then your driver program will try to see under this application what are the transformations and actions. As of now, we do not have any transformations and actions, but what if there are any? So if there are some transformations and actions, it will try to create a DAG. That's what I was trying to discuss yesterday. So it will create a DAG. So based on this transformation and actions, a DAG would be created. So first, initially, that will have your unresolved logical plans. So based on pipeline optimization process, this, so if you let me open that what we have discussed yesterday, so that maybe like you should be able to. So when we were trying to see all these steps, okay, so I'm just trying to recall these steps. So when the DAG, so what it will do, it will try to do the pipeline optimization, which means that your unresolved logical plans will get converted to a physical execution plan, which will contain jobs, stages, and tasks. That's what we have seen yesterday, right? So it will have a pipeline optimization by resolving your unlogical plans into a physical execution plan, and that will contain your jobs, stages, and tasks. Right? That's what we have seen. And then, as soon as an action is called, these needs to get executed. These tasks needs to be executed. Where this task needs to be executed? On some worker nodes. So driver will send this task to your worker nodes. Now it needs to execute it, so it needs to have some resources. So it will talk to your cluster manager. Hey cluster manager, can you give me some resources? Because I've got a request from a user and he needs this work to be done from me. For that I need some resources and I need a help from you. So he will give that help by allocating containers in this executors. Okay? And finally we'll execute, the result will be computed, and they will send the result. That's what it will happen. Okay? Now we have initialized the Spark context. Cool. Now what we will try to do is, see, this week and maybe next week, I'll try to show all the programs in a normal way. I won't go into a functional way where I will try to write functions in some files and I will call those over here, because it would be too early for you to show everything. We'll go step by step. I don't want to create a panic at the start by writing very complex project by a functional approach or a programming approach. So first, we'll get a good grip on writing the programs. Once we get a good grip on writing the programs, then eventually we'll step up, or we'll try to climb the ladder step by step. That's what my plan is. Okay. So the next step over here, what we need to do is we need to read the file. Okay. I have shown you yesterday, we can read the file from edge node. Okay. I can read the file from edge node, or I can read the file from HDFS. Right. I have shown that. So if you go to a folder that is nothing but your data sets, we have a file which has been created for a practice, that is word count file. Also, we have pushed this file, okay, to a specific location which we all know. Okay, that is the same file which should be available at HDFS location also. Either you can read the data from edge node, or you can read the data from HDFS location. Okay, so here we'll try to read from HDFS only, or because I have shown both the ways yesterday, it's how you want to write your code, and no restrictions. Okay, so let's try to read the file. So let me create an identifier or variable name. So I will say this is like read file. Okay, now I have this Spark context. Under Spark context, I have Spark conf. So if we go to PySpark, okay, so this is the latest version of Spark, which is having Spark as a variable. Can you see Spark session is available as Spark? Okay. Now if I just try to type sc and print, it will give me an object, which means that it is available. And if I try to type dir of sc, which from here I will try to get all my constants. Okay, then do I have some methods? Yeah, I do have my methods. Okay, but I do not have classes. I think there is no initial caps. Is server? Yeah, I think there is no. Okay, so initial caps, I do not have anything. So I have some methods and I have some classes. Okay, these are some private reserved variables we'll talk about later. So now what we are interested is, okay, as we have seen yesterday, so we want to use some method from dirsc. Okay, so that is nothing but I need to get a text file method. Okay, simply what you can write is, hopefully we should get this, or else sorry, I should write. Okay, so we are not able to get help over here. Now let's take an example. We do not know what does text file method does, or I do not know from where to get. Okay, so for that what you'll have to do is, okay, so you'll have to go to the documentation. Okay, Spark documentation. Okay, so the version what we are looking, if you want to go with the specific version, you can type that specific version also, 3.0.1 maybe, let's say. Okay, if it's coming, it's okay, it won't make much of differences. Now if you see in this programming guides, you have quick start, you have RDDs, you have data frames, and so on. Whatever we were speaking yesterday, we have all those things. Okay, so now if we are talking about RDDs, so here you will find everything, and hopefully like here you should get all your methods, etc., and you just explore it. Okay, you'll get all the meanings, everything as of now. So it is clearly telling you what it needs to be done, etc. For now we are not worried, because I will be showing you everything what is required. So from the Spark context, I'm trying to use a text file method. Okay, and it needs certain path. So I'm trying to access my HDFS location. So that's why like I'm trying to write HDFS colon on my local host. The port is 9000. And someone asked me yesterday why we are writing this and where I can find this. Okay, so if you remember, maybe like first week class when we were trying to see, second week class, first week second day, that was Sunday, when we were trying to write the Hadoop commands, HDFS commands, we saw some 20 plus commands over there. So at that moment of time, I showed you the file system through a web UI. Okay, and there was one more web UI which I had shown for. One was for resource manager. Do we remember those ports by any chance? And similarly I will get this as well, where my resource manager is. Okay, I did not copy it. Let me copy this and paste this again. And I told you to explore all these things. Okay, explore, you will get to know where all those things, what are my nodes available, okay, what are the applications. As of now we have not submitted anything, so you will get everything. Just explore these things and you will get to know. And hopefully once you go to the overview, okay, so the question was asked yesterday. I don't remember the person's name. Is he available by any chance?
Yes, sir.
May I know your name, please? Sorry.
Amish. Amish.
Amish. Okay, so can you see Amish, localhost 9000?
Yeah.
Okay, okay. So just explore on the things, you will get all the things. Okay, so that's why I've written over here. Okay, then the path which we need to do is user self Hadoop file system input, and my file name is the file name is nothing but my word count.txt. Okay, if you just hover over it, okay, you will get to know what is yesterday. If you see in your interactive approach, that is REPL, when I was trying to execute this piece of command, okay, let me copy this. And when I was trying to execute this piece, if that is correct, I was not getting the output. If that was not correct, I was getting some error, and we were debugging that error and recorrecting that. But now if I want to find out what is this, so here we were typing a type of that object or type of that variable. So we were coming to know that this is an RDD. But here we cannot know that. So you need to hover over it. What it is. Either it's a list, string, tuple, dictionary, or it's a pipeline RDD, or it's a RDD. Okay. So you need to know what the intermediate output is coming. Okay. So it's giving me as an RDD. If you want to see the output, we have seen yesterday what we would be simply writing. What I'm trying to write, I'm trying to write a collect method, action. So what exactly is happening? So if I'm trying to execute this run word count, either you can click over here, or you can click over here, or you can click over here, or you can do right click, or you can run your word count program, or you can use Control Shift 10. All the possibilities are there. Whichever feels comfortable to you and which you are getting accustomed, you can make use of those things. Okay. So now what it is doing? So it is telling me the exit code is 0. The data has been sent to the driver, but are we able to see on the console? No. If you remember yesterday, someone asked me the question, will I be doing the same thing? Yes. If you want to see on your console, you'll have to do that. You'll have to see the output, right? So simply what you can do is simply write a print on top of that, and hopefully you should be able to get your result, or you should be able to get your output. Okay, same thing, there is no difference. It's just that we are writing in a programmatic approach in over here, and when it was a REPL mode, so it was giving an interactive mode. That's the only difference. If you see, I'm trying to get a list, and each list is having one row, and that is a string which is separated by a comma. Okay, so I've explained this line by line yesterday, so we'll not invest much of time over here. So we'll try to progress a little quicker. So we are able to read the file. If you want to comment, you can comment by a hash. If you want to do multiple line comments, we all know what is that. So you can either you can just type hash, or you can press Control/. Okay. If you want to comment multiple lines, select all those, Control/, again uncomment, or you can write triple quotes. We all know those things. Okay, cool. So I'm able to read my file. Now I want to find out an approach for my word count. Okay, so we have seen that yesterday. So what I'll do is, first thing is, what I would do is, I will just count. Okay, or before counting, first if you see the output, The output is single string. So this is the entire row. It is a row, entire row. Remember, if you remember, like last Sunday's session when we were trying to read the CSV files, Excel files, the XML, JSON with Python. Okay, so let's be precise with CSV module. So I explicitly showed you row means like if you recall that indexing concept, data of 0, data of 1. So in 0 I was getting my entire row. So here also it's the same thing in RDDs. Okay, if I just try to write for I in read file dot collect, okay, and see, I just need to give my indentation, and if I just write print I, and if I execute this small piece, okay, I'm getting every row. So that row is nothing but a string. I clearly told you when we were starting Python, you need to remember two things. Can anyone recall me those two things? It's in front of you, which I have highlighted.
The output will be in list.
Yes, that is one of the thing. And the second, the highlighted.
It returns like a Python string.
Yes. So these were the two things which I have already stated you, and that's what we are seeing here also, and we have seen there also. There is no difference. Okay. Cool. So now we will try to make a progress. Okay. So let's make a progress. So now what we will try to do? We'll try to write a. So what we have done, we were able to read the file. Okay, good. So we are able to read the file. Now simply what I will try to do, each line is a row which is a string. So I'll try to split each line into words. Now there are some transformation and actions which are required, which we'll be learning after this. Okay. So for that, what I need, as of now, I'm just writing the code. Remember, just understand, it's not mandatory to understand the code. Just understand what I'm writing. Then afterwards, we'll be seeing this explanation once we start RTDs. So I'm trying to write a split words identifier or variable. So I'm trying to use my RDD. I'm trying to flatten the data, and then I'm trying first the data will be mapped, and then it will be flattened. That's what the meaning is of flat map. As of now, don't worry. I'm using an anonymous function, so that's why I'm trying to use lambda. I'm trying to use my variable, and then I'm trying to write an expression. So row, comma 1. Okay. So what this will give me? So it will separate into words. Okay. After separating into words, it should give me, and before that I missed one thing. So I should have first applied a map, okay, and applied an anonymous function to my variable that is nothing but row, and I should have said row dot split, and the data should be splitted on the base of space. So first we need to split the data. Let's see the output, how the data is looking like. Split words dot collect. Okay, let's execute this and hit it, or maybe let's uncomment this as well and see the output one after the other to understand the difference of the small piece of code which we have written. Okay, so same thing. So if you see, this was giving me the entire list. So now this is giving me a list of lists, and each list is separated by a word, okay, with a delimiter called comma, which is a default one. Okay, so you need to understand all these basic things, because until unless you don't understand, moving ahead, it will be a little problematic. The reason is you don't not understand what is the intermediary output of my code. So whatever the logic which I am writing on my intermediate output, sometimes you will get issues, errors. At that time you will get confused what I am trying to write, what I am getting. So you need to debug. For that purpose, I am showing all like piece by piece. Understand, and slowly by the habit and practice you will get it. Okay. Okay. So I have splitted my words. Cool. Then what the process which I was trying to do a little earlier, I am trying to do now. So what I am trying to do? assign the word with value as 1 because I need to do a word count. So for that process, what I'm trying to do is I'm just trying to write some variable name that is word assign. I'm trying to use my RDD, which is split words, and let's hover on it. What it is giving me? See if it is giving me pipeline RDD, and this is giving me RDD, and now this is giving me a pipeline RDD. So again, like, you need to understand what is the difference between an RDD as an output and pipeline RDD as an output. Okay, again, that's all. These are some questions which I'll be assigning you. Okay, you need to work on those things. Okay, so what's split words? Okay, so again, so here the code which I cut it a little earlier, I'm just pasting that back again. So what I'm trying to do, I'm trying to use a flat map, which is nothing but mapping the data and then flattening the data. Don't worry, I will explain. I'm trying to use one of the anonymous function, and I'm trying to assign to each word. So this, what will happen? This entire list will be broken into each word, and a numeric 1 will be assigned to that. And hopefully we have seen that, so I'll not show that. You can do a print of collect and that, and you should be able to get the output. Okay. Then afterwards, what I'll try to do is simply I will just try to count the occurrences. Okay. So let's say I'm trying to write word count. So that is nothing but my word assign, and I'm trying to use something I'm trying to use. Don't worry about what I'm trying to use, what transformation, what action. As of now, it's not mandatory for you. Okay. So I'm trying to use reduce by key. Okay. I'm trying to use my anonymous function, which will have two variables. One will be the word and the second will be the numeric. And I'm trying to do an associative plus commutative addition. That's why I'm trying to write A plus B. And finally, what I'll try to do is simply I'll just try to print this output, or we can write this output to HDFS. Okay, so the word count, and I'll just saying is save as text file. There are so many sequence file, etc., etc. As of now, I'm going with text file. No issues. Moving ahead, we'll try to explore most of the things slowly and steadily. Okay, so let's scroll a little this and a bit up so that I can just quickly copy this entire path from here, and maybe like I can just paste it over here, and I just need to change few things. It will be written to the output directory, and the output directory name would be created. Let's say word count, and I'm trying to write in my PyCharm, whatever, it's your call. Let's execute this piece of code, and maybe like after that you can write some print statement. Okay, my data has been written successfully. As of now, I have not done those things, so maybe like later we'll start doing those things. If we are getting some errors, see if we are getting some errors. Okay, when we are getting errors, so we just need to scroll over here a little, and we just need to see what are those errors. Okay, so it is telling something like too many values to unpack. Okay, and here if you see, it is getting some Python exception error and fail job extension. So let's go with very top. So something like for key value. So if you remember, like I told a little, means when we was studying Python, I told that Python interpreter sometimes will give you the exact error, or sometimes it will not give you the exact error. At that moment of time, you'll have to understand some keywords in your logs, and based on that, you'll have to identify your errors. Okay, so it is telling me something like something iterator. So this is giving me some value error, maybe like this last line or second last line, which seems to be some issue in thing. That's what I feel. Okay, so maybe like what we can do is simply we'll just try to comment this piece of code, and let's see if we are able to get the data out of this or not. Okay, so let's say print, let's say word count dot collect, and let's try to see the associative, commutative, that reduce by key which we are trying to apply. Is that an issue for us? Yeah, it seems to be that is the issue. Okay, so when we are trying to assign a tuple, okay, so that is nothing but split words. Okay, so we are trying to flatten the data. Okay, so here we should not have used. Okay, so we should have used a map. That is what I am able to do, and here I should have used my flat map. Okay, so let's change a little code here and there. So no, first one is like, again, this is good. So first I'll try to split the data. Okay, after that, when I'm trying to map, so that is mapping correctly. Okay, so that is the first is the I think the splitting should be flat map.
Yeah.
That's, yeah, I'm making a mistake over here. Okay, so it will get, the data will be available in each row, which means that my data would be flattened first on the basis of this, delimiter. Okay, that's where the flatten will happen. After flattening the data, I am trying to apply my map logic. Okay, so I'm assigning the word, and now we should execute this, and let's see what is the error or what is the output. Okay, so errors are always good. Why? Because until unless you don't face issues, you won't learn. And it's not that you need to make those errors every time and repeatedly by knowingly. Okay, it's okay. So now it is giving me the code, and let's write the code to my HDFS file. So it's giving me the output, and finally this should write the data to a certain location which we have specified in my code. Okay, and that, again, it is giving me an issue. Let's understand the issue. Let's go a little right at the top. What it is telling is output directory already exists, which means that the directory which I am trying to assign already exists. So I'll just try to prefix with something so that we'll re-execute this. And again, there are different modes. Someone is not on mute. So there are different modes. Like I can write them. As of now, you got the error. So the default mode is error. Then we have a different modes like error mode. Then we have overwrite mode. Then we have append mode. We'll see all those things slowly and steadily. Okay. So this has written the data to a location, and let's verify that, which should be nothing but just I need to change few things. I just need to go to my output folder, and in that I should be having a directory that name with word count, whatever. Okay, so I think there is some naming convention issue, so let's understand. So wc hyphen pycharm I have used, so let's use that, wc underscore pycharm. Okay, a directory will be created, 2 parts file would be created. Okay, and finally if I do a cat on this, I should be able to see the data. That's what we have seen yesterday, and the same thing which I have recalled again through a programmatic approach in PyCharm. Okay, any questions till here? Yes, no? Are we able to understand? Are we able to, will be able to create the project? Will be able to write the program? If any issues are coming, hopefully we should start debugging ourselves. Okay, and still if you're not able to resolve the issues, you need to share your screenshot of errors in the WhatsApp group. Are we good? Yes, no?
Yeah. Hello.
Yes.
So I joined today itself. So is it?
Okay. So any questions apart from the people like who are attending? Yes, no?
No, actually, yeah. No, sir. I need to type this code, then we'll get to there are a couple of things you told. Yeah.
Okay. Okay. If we are good, so then what we will do is we'll start with RDDs. Okay, we'll try to understand what are RDDs. So, in which layer this RDD falls in the Spark ecosystem?
Core.
Spark core. Beautiful. Okay, so yesterday we have seen in the Spark ecosystem, which I was trying to explain. So this is Spark core is nothing but your RDD. So we have Scala APIs, Java APIs, Python and R APIs, right? So RDDs, that's what we are trying to understand over here. Okay, let's try to understand what are RDDs. So the name itself suggests resilient distributed data sets. Okay, now if we just try to understand this output, okay, so if you see, we were getting how many part files? We were getting 2 part files, right? How we were getting 2 part files? Okay, so what I can do is, we can just go a little down, we can just comment the entire code over here, and I will just say print of read file dot get num partitions, and let's see how many partitions we are trying to get. Okay, so if you see how many partitions we are getting, 2 partitions. That's why 2 part files are getting generated. So this is a default behavior of this virtual machine. Okay, but if you go to the source code of PySpark or the Spark, you will find there is a method or there is a function which is being written. Okay, and that function is nothing but a default. So again, like, let's say what we can do is, where is PySpark? Yes, PySpark is over here. Why it is not clicking? Okay, so we had so this is the second one. Why second screen is hanged? So all 2. Okay, so if you just go to the SO, I think it's default parallelism. Let me, if we get an error, default parallelism, which I think, let's see, or let's directory of SC. So if you see anything with default parallelism, so did I made a typo error? Yes, I made a typo error. So default parallel, even that is correct. So where is the issue? So let me copy this, or we can just write, so sc dot default parallelism. Okay, now if you see, we are getting 4 over here, but here we are getting 2. Okay, so you need to, again this is an assignment for you, so you need to go to your Spark code, sorry, Spark source code. Okay, and you need to find that function where it is using default parallelism comma 2. So when it comes to HDFS file system, so the default is 2, but when we use the AP, when you use the REPL mode and when you write at that moment of time, so apart from file system, you will be getting a 4. So you need to find out, you need to go to the Spark code, source code, and you need to find out that function. Again, that will be given as an assignment. Okay, TK. So you got to know why we were getting part files, and the idea where I went over here was resilient distributed data sets. So when I am talking about the resilient distributed data sets, I think something has happened for me. I'm not able to click, so quickly I'll click. Okay, let's come back. So resilient distributed data set, when the file is being read, okay, what it is happening is the file is converted into 2 partitions, and the 2 partitions are nothing but 2 tasks which are getting executed on the 2 worker nodes. And who are they assigned from? They are assigned from the driver. And how driver is assigning to those executors? With the help of cluster manager, by buying some resources. Hopefully now we are trying to understand the architecture, and slowly we are trying to relate things. Okay, so resilient distributed data sets, which is also known as RDDs, is the primary data abstraction okay, in Spark, which is your Spark code. That's what we have seen yesterday, right? In this diagram I explained you the 2 layers. First, Okay, so the two layers, Spark core and the DSL, then the packages and the libraries is the first part. The second part is your Spark core, and Spark core again comprises of two things. One is Spark engine and the APIs. So Spark core is nothing but your RDD. That's what we are trying to say over here, which is your Spark core. Okay, got to know. Okay, what after that? So let's try to understand what after that. It is immutable in nature. Okay, it is immutable nature, which means that I cannot change my RDDs once they are created. If you go to over here, okay, let's clear off the screen, okay, and let's go to any, let's say, read file. Okay, and after read file, I think I have written small word count splitting. Let me copy this piece of code and let me paste this over here. Now I cannot change this. We know what is immutable. Remember, what are the different data structures which are available to us in Python?
List,
Okay,
tuple,
okay,
List,
set,
map, tuple,
list, tuple, map, set,
set,
dictionaries.
dictionary.
Okay, so out of this, what are immutable and mutable in nature?
Tuples are immutable.
Tuples are immutable, yes. So lists are
Yes.
mutable. Simple, right?
Yes. Yeah.
What about dictionary?
Dictionaries are also mutable.
Mutable, right?
Set is also.
Yes, that's what we have seen. So here, what they are trying to say is, okay, what they are trying to say is once you create the RDDs, they are not mutable, which means that you cannot change the variable value. So, but you can use some transformation and you can transform from one form to the other. So if you see over here, I'm reading the file, but here I'm transforming this RDD from one form to the other. That is nothing but I'm splitting it into words. I'm not changing this identifier or a variable. I'm transforming this by using it over here, and I'm creating a new identifier, and I'm creating a new pipeline RDD. Okay, so that means that once you create an RDD, they are immutable in nature. That is the first. Third thing is they are lazily evaluated. Now what does lazily evaluated means? Okay, now you need to understand transformations and action before to understand this, but again I will give you a small gist as I need to explain you what does lazily evaluated means. Lazily evaluated means is until unless you are not, so let's take an example of a car. Okay, so let's say I'm staying in a building and the car is parked at some place. Okay, or let's try to create a scenario out of it. Okay, so let's say read file. So let's say read file is a car, so I want to buy it. From where I'm buying it? I'm buying it from some showroom, right? So let's say I bought it from some showroom. I bought it from showroom and I got that into certain place. I brought that and I kept into my parking. Okay, then what I did is using split words, what I did some modifications. I added some features to it, maybe like I added some sunroof to it, or maybe like I added cool features like good sound, some jazzy lights. I did something. Am I changing my existing, the core which I got? No, right? So in a similar example, which RDs which I am trying to say, they are immutable in nature. And when it comes to a topic or a lazily evaluated, which means that until unless I do not start my car with a key or do not do an action on that, my car would not get started and it would not take me from one place to the other. In a similar fashion, in this program which we have written over here, we are trying to call an action over here, that is save as text file. As soon as this action is called, whatever the transformations which were written, which were sitting lazily in my parking, that is car, that got into an action, which means that they started working. That's why they say Spark is lazily evaluated. Okay. And finally, what they say is each data set in your RDD is divided into partitions. That's what we have seen. Yes. If you go over here, I think I erased that output, but quickly what we can do is we can get the output, hopefully. Okay, I have not written, so maybe like quickly we'll write get num partitions. Okay, so they are saying us each data set in RDD is divided into partitions. Yes, that's what we have seen. Why? Because to process the data parallelly with a distributed framework, and that's where the power of Spark comes into picture. Processing a huge data on a distributed cluster in a parallel manner, that's where the architecture comes of your Spark. So each data set is divided into partitions which may be which is computed on different nodes of a cluster. Okay, so that is the definition of your RDDs. RDDs are resilient distributed data sets which are immutable in nature and lazily evaluated. They're logically divided into partitions which will be getting executed on my nodes in the executors of a cluster. Any questions in your RDD definition?
Lazily evaluated, can you explain again, sir?
Lazily evaluated. Okay.
Yeah.
What does lazily evaluated means is, okay, so if you see, now when I'm trying to write this, see, when I'm trying to, until unless, let me just comment this line, let me comment this line, even let me comment this line for the time being. Okay, when I'm trying to execute this piece of code, okay, let me execute this. Okay, this is getting executed. Okay, I right clicked and I executed. If you see, what is the output which I am trying to get? I am trying to get an exit output as 0, but I am not able to see the output. Why? Because as of now you don't know whether this is a transformation or this is an action. So what does Spark lazily evaluated means is, whatever transformations which you are using, it will transform your data and it will keep it, but it will not apply that logic until unless an action is called. That's why I gave an example of a car. Car is sitting in my parking, but until unless I don't start it and I take it by driving, I will not be able to get the output of my car. So in a similar fashion, save as text file or collect is an action. Once an action is called, whatever transformations which you have written, which were sitting lazily, they will start computing and they will give you the result. That is the meaning of lazily evaluated. Are you able to get that?
Yeah.
Okay. Any questions on the definition of RDD?
So, Saif, here collect is action, and save as text file is also action, right?
Yes, yes. Don't worry, I will be showing all these transformation actions after this. But yes, to answer your question, yes.
Okay.
So, sir, like RDD is divided into partitions which will be on different nodes. Can we see while running on which node are the partitions going?
It will be very hard because in which technology you are working?
Framework actually.
Which framework?
Hadoop framework only.
Hadoop framework. Okay.
Yeah.
Okay. So you should know this. See, if there is a cluster, okay, when you are trying to write whatever program, let's take an example, you are working on Hive. Is it Amish by any chance?
Yeah.
Okay, okay. So if you are trying to execute your programs, by any chance, do you know, like when you are trying to execute a map reduce program, into which node and which map is working on which node? Do you get to know that?
No.
In a similar fashion, it's like that over here also. If you take an example of a database, Okay, so let's say your client is HDFC, or let's take an example of Lloyd's TSB, which is an example of UK bank, and you are working for that bank. They have their different databases installed on different servers at different locations. When you are trying to create a table, or let's forget about the create table, when you are trying to access your tables, let's say those tables are huge in nature, and let's say you are trying to access your 5 tables, do you get to know which server it is going?
No.
So in a similar fashion, for a developer, we and again the answer is here also, will not be able to get to know which task is processed by which node. But yes, we'll get to know what are the jobs, what are the stage, and what are the tasks. As of now, I only have one node. So under one node, I will be getting all the information. But if you have like a cluster of 400 plus, then it would be very difficult for you to find in a web UI on which cluster, which node your partition is getting processed. So the answer would be no, at least from my end, because I don't know that.
Seth, I think we can check it from job history server.
Yes, we can check. That's what I told. So if you go over here, okay, so this is a job history. Okay, as of now, this is like my first. Okay, it's like a very simple one, right? But what if if I have like a multi-node cluster? That's what I'm trying to say, of like 400 multi-node cluster. Will we able to find that? On which node your partition is getting processed? That's what his question is. If we are able to find, that will be learning for everyone. Maybe like we can just, and again, if you want to find out okay, so what you can do is, so let's say we can just write input, and let's say enter some data. Okay, let me re-execute this code. Okay, so it is waiting for some stuff. Let it wait. Okay, we are not worried about that as of now. So localhost, the port is 4040. Remember yesterday? Localhost 4040, I told. Yes, no?
Yes, sir.
Yeah. If you remember yesterday, I showed you this, right? So that's what, again, I will be showing, but as the question came, so we are just trying to go through there. So here, you will get to know what are the jobs, what are the stages under each stages. Okay, so what are the tasks which are getting processed. Okay, so you will get all these metrics. So if you see two things, now if you see node local, maybe once you go to the real-time projects, okay, so you won't have, because for me it's like a single node cluster, but here you might be having your IP or a pointer to your server. With that, you can come to know, okay, this partition is getting processed to that node. Maybe that can be the answer. Okay, but explicitly I have never done that. So to extent we can get the answer from you. I know this is my first partition and it is getting processed at this node. Okay, maybe I am getting a SMITC technologies over here, but in projects you would be getting your IP, something to the pointer to your cluster nodes. Okay, so does that answer your question? Which partition is getting processed where?
Yeah.
Okay, any questions? Yes, no, are we understanding? See, the reason why I'm going so slowly is because these are the foundations. Once you understand these things, then data frame is just like a cakewalk for you. Okay, cool. If we are able to understand this, so can we take a quick break of 5-10 minutes? Because the definition of RDD. Okay, so now we saw a small word count program in PyCharm. Okay, now let's try to understand some benefits, or maybe in interviews they might ask you what are the benefits, what are the demerits. They will try to ask you. Okay, same whatever it has a capability. Let's say RDD benefits. Okay, so what is the benefits? So the first benefit is in-memory processing, right? because your Spark processes the data in memory, so RDDs are getting processed in memory, and hence the computation would be faster. The second benefit is immutable in nature. Okay, so RDDs are immutable, which means that once you create your RDDs, they are not able to modify. So during the program execution, in between, if you are trying to reference that RDD, it will contain the same value. Okay, so that's why immutable in nature. Fault tolerance. Okay, so it has a fault tolerance. Now, what do you mean by fault tolerance?
So whatever the files has been corrupted might be again.
Yes. So if we recall the Hadoop architecture, okay, so we had fault tolerant with a mechanism, and that mechanism was
Replication.
replication. Beautiful. Okay, so when it comes to Spark, okay, so Spark has a fault tolerant mechanism. How? So if an RDD fails, what it does is it goes back to the earlier RDD, recomputes that RDD, and it tries to give the result. So that is called data lineage. What is data lineage? So let's take an example. We are reading the file. After reading the file, what I am trying to do is I am trying to flatten the data. After flattening the data, I am trying to assign some map. After that, I am trying to do some count. Let's take an example. During this execution, if this got corrupted or this worker got failed or it is not responding. So Spark is so smart and intelligent enough, what it will do is it will go to the earlier stage of that RDD, it will pick that and it will compute to a different node. That's where your data lineage comes, and that's where your fault tolerance comes in your RDD. Okay, so it's a fault tolerant. It's a lazily evaluated, which means that until unless an action is called, my data or my transformations are sitting idly. They are not getting computed. In terms, my resources are not being used. Okay, so all the times my resources are not being used. Only at a particular time some action is called, at the time my resources are used. So that's why like they are sitting lazily. Partition data, because RDDs are getting partitioned to process those partition tasks on my different executors on a worker node. Okay, so these are some features which it has. So if it has features, it should also have some limitations, right? Because every coin has two, or every coin has two faces, or everything has two faces. One is good, one is bad. So if we are seeing good, there has to be some bad. Okay, so what are those drawbacks or what are those limitations? Let's try to understand those limitations. Okay, so limitations. So Spark RDDs are not suitable, that makes updates to the state stored. That's what we have seen because of its immutable in nature. Correct? So what they are saying is Spark RDDs, okay, are not much suitable for application that makes update to the stored state. Okay, so in Spark streaming we have one terminology that is called state store, and it has a different meaning, so let's not get confused in that. So there is one limitation, so it is not suitable for those applications which are doing frequent updates. So that is not suited. Okay, for that application you can use your traditional applications, whatever it is used. So RDDs do not provide you optimization. Okay, so it does not provide you inbuilt optimization, but data frame provides you an inbuilt optimization with the help of catalyst optimizer and tungsten. We'll try to see later, but RDDs do not provide you. Okay, and the thing is again, it is a debatable that RDDs are little complex to write. Okay, so I cannot call that as a limitation, but I can make that a limitation to me, but we cannot talk as global. So as of now we'll speak only for two limitations. Now, how can we create RDDs? How can we create RDDs? Okay, so there are three ways. There are three ways to create RDDs. Okay, so what are those three ways? Okay, so the first method or the first way is with a parallelize method. Okay, the second is from the external storage or external data sets, you can say, and the third is from existing RDDs. So what I am trying to show over here is how can I create RDD? I can create RDDs in multiple ways, and that multiple is three ways. So the first one is I can use my sc.parallelize method, or I can, if there are some external file system, whether it could be like AWS, Azure Blob, or GCS, or maybe like my Edge node, or maybe like my Hadoop file system, I can just reference to that point or location and I can read the data and create an RDD. And once the data is read from the first two parallelize method and external data sets, so RDD is created. From those existing RDDs also I can create a new RDDs by transforming it based on some requirement. So these are the three methods by which an RDD can be created. Okay, let's see quickly. So the first one we'll try to understand is so the first one is nothing but your parallelize method. Okay, so how I can do that? So let's say I'm trying to create a data. Let's say the data is something like 1, 2, 3, 4, 5, 6, 7, 8, 9, and let's say there are some 10 elements in a list. What you can do is I'm creating an RDD with the SC method. Now here I'm trying to use my parallelize method and I'm trying to pass my data. And simply what I'm trying to do, if you want to see the data, you can run an action that is rdd.collect. Okay, and simply your RDD should be able to get generated or created. Okay, so let's clear off the screen and let's execute these three statements and let's hit enter. Okay, so if you just try to run type on top of this, okay, so this will give me a list and this will give me an RDD, okay, which we have seen. So I can create an RDD from the data also, which can be cooked or given during the runtime with a parallelize method. So that's what they are trying to say. So the first method is parallelize, using the parallelize method. Okay, so if you remember a little while earlier when I was trying to execute the code in my PyCharm, okay, let me stop this. When I was trying to execute the code in my PyCharm, I had written a small syntax and that syntax was get num partitions. How many partitions I was getting? I was getting 2 partitions. But here if I try to do rdd.get num partitions, I should get 4. rdd.get partitions. Okay, so that's where you'll have to dig in your Spark source code and you'll have to find out that function for me. That's where the function has been defined. If for default parallelism for the Spark context, it should be used as 2 when it comes to HDFS file system or file system. Otherwise it will be whatever default parallelism, it's a 4. Okay, cool. So I'm able to understand this. Okay, I'm able to create my RDD. Also what I can do is, okay, if I want to see, let's go back. Okay, let's say if I am trying to do rdd.collect, I'm trying to get this data. How many partitions are there? 4 partitions. I can see the data within each partitions also. How? With a gloom method. I will be able to see the data in each partitions. If you see in my first partition, I have this data. In the second partition, I have this data, and so on. Okay, so what is the method? Gloom, which reflects or which shows the data from your individual partitions.
Sir, Irfan here.
Yeah.
So on which basis it make the partition? On which basis it make the partition? Because here.
Hello. Am I able to hear?
Yes, yes.
Seth, can we see individual partition data through RDD?
So here we are trying to see that only, right?
Yes.
Individual
It is
partition data.
no, suppose if I want to see only third or fourth,
So get the
like
list. How we will get this? This is the zeroth
okay,
element. This is the first element.
okay,
This is the second element. This is the third element, right?
okay.
What you will write? Simply you will write second element. I'm getting this. Python. We have studied this, right?
Yes.
Okay. Cool. Let's come back. So I can create my RDD with a parallelize method, and I can see the partitions. What I can do is, with my own way, I can create the partition. I can create my RDDs with my own partition also. Yes, I can do that. How? Simply what I will do is I'll just quickly copy this piece of code over here. Okay. So what I'm trying to do, I'm trying to create, so this is a data, which is a list that has been created. Okay. And here, when I'm trying to say sc.parallelize method, when I'm trying to call that list, simply I will just pass how many number of partitions I want to get. That's it. Your work should be done. Okay, so now we are getting 3 partitions. So you can create the data with partitions, but again, like as a data engineer, we do not do these things. But again, these things are basic, so you should know this, because mostly like we would be playing with huge files internally, how that would be splitted into the number of partitions, then how we can optimize it. So based where there we'll have to focus more. But again, like as the topics are there, so I'm just trying to cover. So partitions, I'm trying to. Okay, so this is the first method when I can create my RDD. Okay, the second method which we all know and which we have just seen a little while earlier, that is nothing but reading the data from my external data sources, right? So I don't think so like I need to show this external data sets. Okay, so simply what I'll do is I'll just read the file and I'll just do print or collect. I should be able to get the data. And the third thing is from existing partitions. Again, we have seen this, right? How? When I'm trying to read the file, I'm trying to convert that from one RDD to other RDD. So that is like once the file is being read, okay, from this I'm trying to transform from one RDD to another RDD. So these are the 3 approaches which they say I can create an RDDs. So are we good till here? Yes, no?
Yes, sir. Yes.
Cool. If we are good, so let's now enter into the world of transformations and actions. Okay?
Sir,
Yes.
can you write the command here? Gloom, RDD gloom,
Okay,
to
okay.
see the partition.
Okay, okay. So that is RDD. Okay?
Yeah, thanks.
Cool. So now let's understand. Now we got to know the Spark definition. We are slowly understanding the Spark architecture and its behavior. We are able to recognize the ecosystem. We are able to recognize what is the core of Spark, that is RDDs, and we are using Python APIs to interact or write programs in PySpark. Okay, we were able to interact with REPL mode, Jupyter, and PyCharm. We were able to create or configure our project in PyCharm. And now we are able to understand what is RDDs and how can we create RDDs. Now we'll take a next step and we'll try to understand what are the transformations and actions that I can use to achieve my requirement, whether when a requirement is presented to me either in the form of assignments in training program, or once you go to the project, the requirements presented by the client. So what transformations and actions you will perform so that you will get the data. So we are trying to understand that. Okay, cool. So let's first understand what are transformations. What do you mean by transformations? As the name itself suggests. Okay, so transformation. Okay, so transformation are operation which will transform. What it will transform? It will transform your RDD data from one form to another. Correct? That's what we have seen. If you see, I am trying to read this file, and this is becoming as an RDD. Then I am transforming from one form to the other form. So again, this is becoming another RDD. So what I am trying to do? I am trying to apply some transformations. That's why flat map is an example of a transformation. So what does transformation do? Transformations are operation which will transform your RDD data from one form to the other. Okay, and when you apply this means, and when you apply transformation, okay, you get a new RDD, or you get a new transformed RDD. That's what the definition says of RDD. So in transformations also we have two types of transformations. One is narrow transformation and the other is wide transformation. Okay, so we understood what is the definition of transformation. So inside transformation also we have narrow and wide. So let's understand what is narrow transformation. Okay, as the name itself suggests, transformation, your RDD will be getting transformed from one form to the other, plain and straight and simple. But what does narrow means? In narrow transformation, okay, in narrow transformation, all the elements that are required to compute the records, okay, in a single partition lives in single parent partition RDD. It's a lengthy statement, but we will try to understand. Okay, so what does the definition says is, in narrow transformation, all the elements that are required to compute the records within a single partition lives in single parent partition. Okay, let's understand an example of it. Okay, so let's open a paint. Okay, so what we will do is, let's take an example of, let's say this is first RDD, this is second RDD, and let's say this is third RDD. Okay, so what I am trying to do, so let's say this is, so let's say this is your first partition, this is your second partition, and this is your third partition. We all know RDDs are divided into partition, right? I hope like I'm trying to make sense when I'm trying to say something, because that has been already taken care a little back earlier. So RDDs are resilient distributed data sets which are divided into logical partitions. So these are my partitions. I'm trying to understand my narrow transformation. Now what does narrow transformation means is, so let's consider this is first partition, this is second partition, and this is the third partition. When I'm trying to do some computation, okay, or let's take this. Okay, so let's Control C, Control V. So when I'm trying to do, so now what will happen is, okay, let's consider I have the data like this, 1, 2, let's say 3, 4. let's say 5 comma 6. Okay, so I've just taken 6 elements in 3 partitions with 2 element each in 3 partitions, right? Now what I'm trying to make you understand is narrow transformation. So let's say I'm trying to write a small logic. I'm trying to write a small logic, and that logic is nothing but let's say map. Okay, so in this map what I'm trying to write is, let's say I'm trying to write whatever the elements which are coming, I want to multiply that elements by 2. A simple, just to make you understand. So now this computation will happen on individual partitions parallelly, right? That's what the definition and that's what the architecture says to us. So what will happen is, this 1 will be passed to x, 1 into 2, I will get 2, 2 will be passed to your x, 2 into 2 will be 4. Similarly, 3 into 2 will be 6 and 4 into 2 will be 8. The third one is 5 into 2, it will be 10, 6 into 2 will be 12. Now what the definition says to us, what we want to compute the records in a single partition lives in single parent partition only, which means that when I'm trying to apply some computation, that data is coming from a single parent RDD only, that is not coming from multiple RDD or multiple partitioned RDDs. So whenever there is a output or whenever there is like a one-to-one representation, those transformations are termed as narrow transformation, which means that the computations which will be applied will be available in only same parent partition RDD. Am I making clear? Yes, no?
Yes.
Okay, thank
Yes,
you
sir.
so much. So that's where there are different types of narrow transformation. What are the different types of narrow transformation which I will show you? The first is map. The second is flat map. The third is the third is, I think it should be small, map partition. Okay. The fourth is filter, and then let's say union. These are sufficient just to make you understand. Okay. Let's try to understand now how does the narrow transformation each will behave. Now if you see in the word count program, I have used map. Now what is map? Map is a narrow transformation. Okay, Saif has told, so that's why it's a map, is a narrow transformation. But what exactly is map? What map does? Do we know? No. As of now, we don't know. So what is map? So we'll try to understand what is a map. So what map does is, it returns a new RDD. What it does? It returns a new RDD by applying what? By applying a function, okay, to each element in RDD. So that's why I was trying to give the example of map. So now if you see, when I'm trying to write a logic when I'm trying to use a narrow transformation, that is map, what it is trying to do, so let's eradicate this. Okay, I'll come to so that was like narrow transformation, but I'll explain you again this. So it's the same explanation, but let's start again. So returns a new RDD by applying a function to each element. That's what it says. Let's take an example. Okay, so you have an RDD, and that RDD is nothing but, let's say, 1, 2, 3, 4, 5. Just a small list. Okay, I'm trying to write a small logic. What logic I'm trying to write? Let's let's say this is, so what I'll try to do, so I'm trying to create an RDD. Okay, so let's say this is A as a some identifier. Okay, so I'm trying to write a dot map. What it is telling me, it returns a new RDD by applying a function. So what function I'm trying to apply? I'm trying to apply an anonymous function. You can apply any choice of yours. I'm trying to apply an anonymous function that is lambda. I'm trying to assign a variable, and as discussed, I'm trying to apply some expression to it. Okay. Then if I try to do rdd.collect, what exactly is happening? The same thing which I showed a little back earlier. Okay. So now what exactly is happening in this scenario? We have an RDD. What we have? We have an RDD. What we have? So here we are having an RDD, and that RDD is having a data, and that data is nothing but 5 elements. And we are trying to write a small function or a logic over here. This is what we are trying to write. And what does map says is, it tries to apply that on all the elements. So whatever I have written, so this was the stuff which I have written earlier, same thing. So in my map, whenever I'm using map, whatever function or logic I'm trying to write, that will be getting applied on all elements of your RDD. That's what it says. So x into 2, 2 into 2 is, so 1 into 2 is 2, 2 into 2 is 4, 3 into 2 is 6, and so on. So if I execute this small 3 lines of code, what exactly is happening is, my map function, okay, so my map function, what it is trying to do, it is giving us some error. It is telling list object has no attribute dot map. Okay, cool. Now let's understand this error. What I'm trying to do, I'm trying to create a list, and on top of that I'm trying to apply a function, a method which is available with PySpark under SC object, right? So that's why it is telling me list object. So this is a list. If you just write type of A, and if I just do date of A, I do not have a method or an attribute by the name of map. So see, these are the sorry, it is giving me an attribute error. So you need to identify these errors slowly and steadily. That's your learning curve will increase. Okay, what it is telling is, the map which I am trying to apply is not available in list. Use something different. So what I will do, simply I will say sc dot parallelize. I know how to create that with a parallelize method. Now I will copy this, clear off the screen, and execute this piece of code, and I am able to get now. It is not complaining me. So the idea behind explaining the map as a narrow transformation is, it applies the function on all the elements of a list, and it gives us the same number of elements. That is a very important point. What it gives? It gives the same number of elements. Okay? So next Saturday, hopefully, if we finish today all the transformations and actions, which I assume will not finish because I'm going too slow. Because next Saturday was plan of implementing one use case of movie lens. Hopefully, we'll try to see. So next Saturday, you will come to know how can we use this transform and actions, and based on some requirement given to us, how can we achieve the output with some use case. Okay, and also by the end of the class also you will get some assignments. Yes, someone was asking question.
Yes, Saurabh here. Is it creating multiple partition here?
No, it is not creating multiple partitions. If I just try to do rdd dot gloom and they even get num partitions. So it is having the same constant. Unless you do not do coalesce or repartition, your partitions count won't get changed. So to answer your question, no. So can we understand now the map function or map method to be precise? Yes, no?
Seth, I might be getting confused, but earlier we could see that previously it created some partition.
Mm-hmm.
Now it is not. So is it just that with map transformation it is not creating the partition?
No. It's nothing like that. If I just try to do collect, you will get the partition data. 4 partitions and you're getting the partition data.
Okay, I get it.
Okay? Okay. Any questions in map transformation? Are we able to understand? So whatever logic or function which we are applying, it will be applied on all the elements and the output will be the same number of elements. Are we good?
Sir, you have said that map transformation is applied on a single partition, right? But this already
Where
has
did I
four
say it is applied on single partition? I am trying to say it is applying a function to each element in RDD. So what is the RDD now? Your RDD is having all these elements, right? So whatever function or whatever map logic I am trying to write, that will be getting applied on all the elements.
I mean, you said it is a narrow partition, right?
Mhm.
Narrow partition. You mentioned that it is applied on the single, which is parent to single partition level in a single parent.
Mhm.
But already has partitions has 4, right? Default if you select
No.
okay.
You are getting confused. See, this is the RDD. Okay. Let's say we got 3 partitions. Got it? Yes, no?
Yes.
And we are getting 3 partitions. Now I want this logic will be getting applied, right?
Yes.
And I will get an output, right?
Yes.
Okay. So ideally I should get 3 partitions, right?
Yes.
Okay. Now when I am trying to apply this logic, so the data is available in this partition, so it is not dependent on multiple parent RDD. So the outcome of this, which is nothing but 1 2s are 2, 2 2s are 4. So the logic or the output which is required from this computation, it is coming from a single parent RDD, not from multiple parent RDD.
So, Saf, it's not going for shuffle of the partition,
Yes, it is not shuffling the data. That's where your white transformations are costly transformation, because the data is shuffled and the computation is done. So the data is shuffling over the network and it is giving us the degraded performance. So that's why narrow transformations are the best transformations. So do I answer your question that these calculations are coming from a single parent RDD? If I want to get like output of 6 and 8, do I need to go over here? No, na?
No.
I need to go to only one person, that is the parent RDD. That's why it is said returns a new RDD by applying a function to each element, and that can live in a single partitioned RDD. Got it? Yes, no? Because that looks okay. ठीक है. Okay, if that is good, so let's make a move. So any questions on map as a method?
No.
No, thank you. Then we'll try to understand flat map. Okay, what I told you earlier, I told you about flat map is, okay, So what it does, it returns a new RDD. What it returns? It returns a new RDD by applying a function. By applying a function to all elements of RDD, okay, and then flattening it. Okay. So the key difference between map and flat map is, and this is an interview question, map returns the same number of elements. What it does? It retains the same number of elements, or you can say it returns only one element as a
Voice is
list.
breaking to me.
Okay, let's see. What I was trying to say is the difference between map. So what flat map does is it returns a new RDD by applying a function to all elements, same like map, but it flattens the data. When it flattens the data, so we do not get the same number of elements. So the key difference between map and flat map is map returns the same number of elements, okay, and flat map returns multiple elements. Or let's write in a good statement. Map returns only one element as a list, I can say, okay, and flat map can return a list of multiple elements. Okay, we'll try to see the difference and you'll get to know. If you remember the difference where I was trying to show, hopefully that I showed a little earlier, maybe like yesterday I think, when we were trying to read the file. Let's see that scenario again. Okay, so when I'm trying to apply this, let's welcome @123. Let's clear off the screen. Okay, now if you see, when I was trying to write this, okay, and I think like when I was trying to apply, okay, so I need to, it's like too long, so let's come back quickly. So I had applied this. So split words, let's say in spite of, we will say F, okay, and here we will say M, and we will just release, or we will just make a change of this. Now if I try to do f.collect and if I do map.collect, understand the difference. Let's come back. What I'm trying to say, let me see. Returns a new RDD, okay, by applying a function to all the elements and then flatten it, okay, that is okay. So the key difference is also that is fine. Now let's try to understand.
To make a correction in the definition, returns only one element. You are not mentioned just one.
Returns a new RDD by applying a function to all elements of RDD and then flattening it. It's again like way of interpreting. Again, in my own words it would be different, in your words it would be different. It's not the firm definition which I am taking from some documentation. It's like in my own words. You can reframe as per your understanding. Okay? Because here if you just say, if I just write for I in m.collect, okay, and if I just say so, now are we able to get this? See, we are getting a single element, but if you see, we are getting multiple rows. So that's why again I have not written it. Okay? So let's come back to the explanation. Let's delete this quickly. Like we will try to take some 3 partitions. Okay, and I was taking, that's the same example. Let's say I have like 1, I have 2, here I have 3, here I have 4, Here I have 5 and here I have 6. When I'm trying to see an example of flat map, what they are trying to tell, it's an example of narrow transformation, right? So definitely it will have, what it will have, the computation will be available in the
Function.
single parent partition, right? So when I'm trying to apply that logic, that is maybe like x into 2, that logic when I'm trying to apply. So this x is getting applied on this also and this, and that is available in a single partition. So if you remember, what flattening map does is, first it applies a map and then it flattens the data. So what I'm trying to get? I'm trying to get here 2, 4, 6, 8, 10, 12. What is done? It has applied a function to all the partitioned RDD living in the same parent RDD, because it's an example of narrow transformation. After applying the map, it is trying to flatten each row or each element, you can say. So the outcome is, so the 2 and 4 will be flattened like this. 6 and 8 will be flattened like this. 10 and 12 will be flattened like this. So the input RDD and the output RDD elements are getting changed. So this is a very important distinction between your map and flat map. So that's what we were trying to see an example over here. When I'm trying to write a map of split, and when I'm trying to write a map over here, and when I'm trying to write a flat map over here. Let me clear off the screen and reiterate those statements again. F. Then I will just try to write this is my flat map. Okay, and I'll just change this to M, and I'll change my method from flat map to map. When I'm trying to write for I in M dot collect, okay, and we will just try to print this I. Okay, so I'm getting this. Now let's try to do for I in F dot collect. Okay, 1 2 3 4, print of I. First what it will do, it will apply a map logic. After applying the map logic, it will flatten the individual element. Okay, so that's what the explanation goes over here. Are we able to understand what is map and what is flat map? Yes, no, maybe. Is my voice audible?
Yes, sir.
Yeah,
Yes.
so whenever the question is asked, to respond please, because it's for you. If you're not able to understand, then I need to reiterate again. Okay, cool, good. So we are good with map and flat map. Very basic, but good, because now moving ahead, we will be writing so many logics at that moment of time. You need to decide, what should I use? Should I use map or should I use flat map? You need to make a call. Okay, okay. Let's understand a filter. Plain and simple, right?
Sir, what would be the output of flat map? Is it a list?
Sorry. Everything is, as of now, it's a pipeline RDD. Okay, because it's an intermediate process. So it's an RDD, but it's a pipeline RDD. It's
So
not.
for flat map also it's pipeline RDD. Huh?
Yeah, it should be.
Okay.
See, we are not. Because this is a question which I will be giving you. You, as of now, you do not understand the difference between RDD and pipeline RDD. So read file. Okay. See, if you see, when I'm trying to read the file, it's an RDD. Means from this class, I have an RDD. But when I'm trying to apply some methods, they are pipelined RDD, which means that I have applied something logic on that. So if I want to get something out of it, I'll have to store into some, or maybe then afterwards I will have to apply or collect or do something on top of that, because they have been transformed and kept. So that's why they are called pipeline RDD. But again, to answer whether it's an RDD or a list, it's an RDD. Okay.
That's one question I have.
Yeah. Yeah. Tell me now.
Sir, so are we changing the partitions also when we are doing flat maps?
See, the same question again, like it's coming again. So what if you remember, like earlier and now also, whenever you execute your code, or when your user submit your code, or let's say, may I know your name, please? Huh?
If your voice.
Thank you. Let me resume. Now, Obed, so when we talk about partitions, okay, so when we are trying to read the RDD with a parallelize method or a text file method, the partition count will be either 2 or 4. This is of my VM, huh? I'm not talking about the real times. And this is I'm focusing on my VM. So when I'm trying to read, I'm trying to get some partition count. I'm trying to apply some logic in between, right? And then finally, I'm trying to write the data. Okay? So it depends on you if you want to change the number of partitions. If you're not doing that while reading and while writing, the partitions count will not change. That's why if you remember, when we read the file, the count was 2 and 2 part files were written. But what I can do is, I can change the partition count also in between or while writing also. So as a user, you need to do it. And there are methods like coalesce and repartition that will change your partitions count. But to answer your question, partition counts are not changing. So am I making clear? So partition counts are not getting changed.
So it will be immutable. Whenever we want to change it, it will be changed. Otherwise, it will not
Yes,
change.
it will be constant.
Okay. So whatever the actions or transformation we apply, it will be same.
Actions and transformations will applied on each individual partition RDD or RDD, and based on that your output will change.
Okay.
ठीक है? Yes, no?
Yes.
Okay, cool. So we know filter, so I'll not invest much of the time. But again, like let's write a small statement to understand that. What it does is, it returns a new RDD, okay, by applying. It returns a new RDD by applying a function to all elements of RDD. ठीक है? So filter functions a new RDD by applying a functions, and sorry, let's reframe this. Not looking good to me. It's not looking good. So what does is filter returns a new RDD, okay, containing only those elements which are meeting the conditions that will get applied on all elements. Okay, see, these definitions I'm trying to write on my own words, okay, but if you go to the documentation, so it will be like how they have given, but here I'm trying to write in my own words, so you just need to understand the difference. Okay, as it is an example of narrow transformation, and as someone suggested, it will not shuffle the data. Okay, So what we are trying to do, simply I'm just trying to take, I'll just do quick copy paste just to save some time, okay, and move a little quicker. Now what I'm trying to do, I'm trying to create an RDD. Now you know how to create an RDD, right? And here I'm trying to apply a logic. So in place of map, I'm trying to apply a filter. Okay. In this filter, I'm using an anonymous function where I am saying, okay, the expression or the logic that is, let's say x of modulus of 2, x of modulus of 2, if it is equal to 0, filter those elements. So this logic will be applied on all elements which are meeting this and giving the predicate, it will give me the output. So like where clause in your SQL. Okay, so I think like it's a straightforward, not much different, nothing much to show over here. Okay, so what is the filter? It will just filter the data. Okay, now let's try to understand map partitions, and this is a little tricky, not tricky I would say, but let's understand. So map partitions, okay. Now if you understand, we have just recently seen, what we have recently seen, in map a function is applied to each and every element of an RDD and returns a new RDD. That's what we have seen, right? Correct. So let me quickly copy that statement over here. So this is the statement which I have written. Okay, so let's quickly write that. Now when we talk about but in map partitions, the name itself suggests the logic or the function will be applied on the partitions. Okay, as Saurabh asked, can I get the partition data? Yes, I can get the partition data and I have shown that. But can I apply some logic to individual partitions also? Yes, I can do that also. That's where your map partitions will come into picture. Okay, so in case of map partitions, okay, in map partitions I will say, we'll just write in map partitions, instead of each element, the function is applied to each partitioned RDD. Okay, and I will show you with a small stuff how it is working. Okay, and returns it returns a new RDD, and will it give me multiple elements? And I think so, and returns multiple elements of RDD. Let's see, because I'm able to recollect that. And in map partitions, okay, so that is okay. So but here when we are trying to use map partitions, okay, as it will be applied on each partition, okay, this is a very important point for map partitions, and let me write that. In map partitions, okay, transformation works on each partition. That's what we know with the name itself. But it takes, what it takes an iterator. Can you tell me what are the examples of iterator which we have seen in Python?
Next.
List, beautiful.
Next.
And what else? All the data structures, right? I can traverse on all the data structures. I can traverse on my list. I can traverse on my set. I can traverse on my tuple. So it is, if you remember, I am traversing. So I am not doing nothing but I am iterating. Okay? Let's understand with a small example. So let me create one RDD. Okay? sc.parallelize method. Parallelize. Okay, in this I am trying to write some elements from 1 to 10, 8, 9, and finally my 10. To give a demonstration, I will create my 2 partitions. By default, how many partitions it will create?
4.
Beautiful. So I am saying no, I only want to show some example. I'm creating a function with the name f, which will take two parameter. Not, I'll show that later. Let's not confuse you. I'll take only one parameter, and that parameter would be, let's say, I. Anything, it's your call. Okay. Yield. What is the yield? Yield takes the output from a buffer. You just need to remember that as of now, because I need to explain yield at a later stage. And I'm trying to do sum of I. Here what I'm trying to do, I'm trying to write a small function which I am trying to do sum. Okay. After, where it is, after I'm trying to do sum, okay, and I'm trying to yield that. That's what it is. Now I will simply say result equals to, okay, then I have a dot map partitions. Okay, in the map partitions I'm calling the function. If you remember earlier, I was trying to pass a anonymous function, but here I'm trying to create my function and I'm trying to pass that function. You can do the same thing over here also. Okay, good. If you are able to do that, and simply then what I will do is a dot clume dot collect, and if all goes well, we should get the output as well. Let's see. Let's execute that statements, and there are some issues. So it is telling result is a dot map partitions. Okay, so something is fishy. Let's check. So what I'm trying to do over here is with the a dot sc dot parallelize method. Okay, so this is a list which has two partitions. Okay, that looks good to me. Then I'm trying to create a function. Okay, so that is doing a yield, and I'm trying to do some. So a dot map map partitions. I'm trying to pass the function. So let's see. Intermediate result is giving me an error, right? So okay, I got the issue. Yeah, indentation. The issue is, like, again, like, this is a function and it needs some space because it's a REPL. Done. Okay, let's come back and let's execute this piece now. You can do in IDEA if you don't want to face this issues of indentation. Okay. So now what we are trying to do is we are trying to get two partitions. Okay. And I did not do a result. So here I should have done result. So we could have got the sum of those two partitions. Okay. Now, can you see I have created two partitions of this? Yeah, I created two partitions. It's breaking. Okay, so here if you see what I have done is, we all know I have created a RDD with two partitions. I can see those two partitions. I have applied a function which will do sum. So when I am trying to apply a sum on this partition and I am trying to do on this partition, I am trying to yield that. Yield means whatever the outcome of this which is stored in the buffer, I am trying to fetch that. That's why the yield comes into picture. Okay, so I'm just applying a sum on these two partitions. So this sum is 15 and this sum is 40. So it is applied on each partitions, not on each elements. Are we able to understand the difference between map and map partitions?
Yes.
Yes?
Yes, sir.
Yeah, thank you. So let's go ahead. So this is, let me quickly copy this so that, or even like this, that was correct. We just needed to enter that. Okay. And here you just need to see, you just need to see the result as well. So print that as well. Okay.
Sir, here
Yeah.
we are not making any change with this A, correct?
No, because they are immutable in nature, right?
Yes.
So I'm trying to create one more way identifier, and then I'm trying to make that, apply that function, and I'm trying to use that, apply some function, and whatever the change is coming, I'm trying to store in this RDD. ठीक है.
Sir, on what basis it has divided the elements into two partition? Just counts and equally
Same
distributes?
question again. As I told a little back earlier, it uses internally hash partitioning.
Okay.
Okay. Internally, there are different types of partitions which are being used. So we will be seeing later. There is a hash partition, there is a sort merge partition, there is a bucket partition. We'll see. As of now, it's too early. But to answer your question, it is using hash partition. ठीक है? Yes, no?
Yes, sir.
Okay, cool. Okay. Let's see now. Okay. So, can we take a quick break of 5 minutes? Okay. Okay, so we have seen map partition. Okay, cool. Now, we have one more transformation which can show us the index also. Okay, so let's quickly see that. So that is called map partitions index. Okay, and it will take two arguments. That will be index and it will be function. Okay, so that's what it will take. So first understand like what it is doing is same like your map partition, only it will show your partitions also. That's the only difference. Okay, let's understand. Sorry, it returns a new RDD by applying a function to each partition RDD while showing or tracking the index of the partitions. That's the only difference, nothing else. This code should be almost same. So what we will do is we will copy this. Okay, what I'm trying to do is I'm trying to use a parallelize method and I'm trying to create an RDD. Okay, as it is expecting two arguments earlier. So what I'll try to do, I'll pass two arguments. So one is like index and the other is variable. So here also at the time of, I'll just call this index. Okay, so not like this. I think in the yield, yeah, let's do some changes. So when I'm passing to this, so it is yielding it, then it should have, yeah, so one will be taking my index and that is nothing, the first argument, and then I will do my sum of I. Okay, so yield it will go and good. Yeah, looks good to me. Let's copy this and paste this. Okay, so let's enter so that both codes can be seen at one view. Okay, and simply what I'll have to do is I'll have to do the same thing. So I'll just call this. Okay, and let's execute this as well. Something fishy. So illegal position. Okay, okay. So something is like in the statement I have not provided correct. Let's go back to the copy paste. So here I should have passed. Okay, so here first of all the method which I am trying to pass, that is not correct. Okay, so that is map partitions with index. Sorry, so it is map partitions with index. Okay, so here I'm trying to pass that f, that is nothing but function, and now it should give us the right result. I think that was the reason it was giving us the error. Okay, we are getting the same error. There is no difference. The sum of first partition and the sum of the second partition. Earlier we were giving 15 and 40. And if you see, this is my 0th partition and this is my first partition. There is nothing much to add into this. Okay, it's only like we are tracking on which index what we are getting. So if you want to go to that depth, you can go. But again, like nowadays RDD is not practiced much. Okay, let's understand union. We know what is a union. Okay, so it will, so union, UNIO. So union function will get the elements, okay, of both the RDD to a new RDD. Okay, and the key rule which you will have to remember is the two RDDs should be of same type. Okay, and just wait a minute. So that's why I just okay. So what I will do is I will try to quickly say, just take this. A.sc.parallels. For the time being, I'll try to remove this partition. Control C, Control V. Okay. I will just try to take B, and I'll just try to. Okay. So what I'm trying to do is I'm trying to create two RDDs. Okay, with the parallelize method. Okay, or like let's do one thing, because I'll have to show some demonstration of like some repeated words also. So let's say repeated elements. So I will just write 1, 2, 2, 3, 3. Okay, I'm trying to do. So simply what you can do is, okay, A dot union B. Okay, and we should be able to get the data as expected of the statement which I have written. Let's clear off the screen. Okay, so it can contain duplicate also. It is a union of two data sets, and finally we are getting. And again, like if you want distinct, again there are so many methods which we will see. As of now, I'm just covering few to make you understand, because in data frames we will be going a little deep. In RDDs, that's not much required. Okay, so again, like there is one distinct. If you want to remove like apply like distinct, you know what distinct does. Okay, it will remove the duplicates. Okay, so I'll not explain that. So you can try on this, and if you're facing any issue, let me know. Okay.
Sir,
Yeah.
so it's the same time or same type?
Same type.
Okay. But you have written same time.
Sorry. My typos are always like very great. Thank you. Thank you for checking it, and thank you for correcting me. Okay. So you can check. You can do this thing. Two things. I hope like you should be able to do. Okay. Distinct will give me the unique
Sir,
elements. Yeah.
sorry to this, sir.
No issues. No
Like
issues, brother.
you have mentioned here union, right? So it is also including the duplicate
Yes.
thing.
That's what I said. Na, it can contain duplicates.
Yeah. So do we have any union all also here? Like we have.
I think we have in Spark data frame, but I'm not able to recall whether it's available in RDD. You'll have to just do dir of SC, and you will get all the methods available.
Okay.
You'll have to do cross check. But because I have never worked on RDDs, mostly like now, if you see, in the early days when the Spark started in the 1.x method, people used to write the code using RDDs. Nowadays, everywhere you'll find data frames.
So these functions are not there in data frames.
Relevant to this, there are different functions. So filter is available. Okay, map partition. So again, we'll have some equivalent functions available. If it is not available, what we will do is we will convert the data frame to RDD. We will apply that logic, and then we'll come back to data frame. That's what we do.
Acha. Okay. Got it, sir.
Okay.
Yeah.
So
Yes. Thank.
distinct and intersection, I hope you should be able to do. Now comes a good important point of discussion, and that is nothing but group by key. Okay, to make you understand between the narrow transformation which you have understood now, so let's try to understand the wide transformation. Okay, for that I'll have to represent something. So let me draw a few boxes. 1, 2, 3. Okay, what I'm drawing 3 boxes, and finally I'm trying to draw 2 boxes, 1 and 2. Okay, now let's say I have a data, and that data is something like this. So this data is a comma 1, and let's say this is b comma 1. Okay, whoops, I hope that, yeah. And let's say here I have the data like a comma 1. Okay, then I have a comma 1 again. I'm just cooking some dummy data to give you some explanation. Okay, b comma 1, and finally b comma 1. Okay, and I can quickly just copy paste this because I don't want to type it again. Let it be same or same, no issues. Control C, Control V, and let's take this over here. Okay, cool. Now we as of now we were trying to understand the narrow transformation. So now I'm introducing you to the wide transformation. So first let's understand the definition of wide transformation, correct? So the definition of narrow transformation is when we are trying to do computation, so the partition RDD can be available only in one parent RDD. Okay, but when it comes to transformations, but when it comes to wide transformations, okay, in wide transformation, all the elements that are required, okay, that are required to compute the records, okay, in the single partition, okay. So all the elements that are required to compute the records in the current partition, okay, may live in one or many parent RDDs. Okay, so the difference is coming over here. The second difference is a very performance related. So wide transformation, and someone also catch that. So wide transformations are also known as shuffle transformations because they may or may not depend. Let's not write that. It's a shuffle transformation. Okay, so wide transformations are also known as shuffle transformations. So I'm trying to explain you the definition of this. Okay, I have written some definition. Now I'm trying to explain you a small example. The example is nothing but what I want to do is, based on the key, I want to find the count. Okay, based on the key, I want to find out the count. And as the name itself suggests, group by key. GROUP, group by key. As the name itself suggests, it needs to have a key and value pair. That's where I have designed or I have created a key and a value. Okay, so a key value pair. Okay, that is done. Okay, let's consider these are three partitions. Okay, or let's say not partitions, let's say these are like three parent RDDs which are available. Now what I want to do is I want to find out based on key. Okay, so when I'm trying to apply this group by key, so what will happen is the computation will happen and some associative commutative whatever logic I will write, but I need to find out the count of A and the count of B. So if I want to find out the count of A and if I want to find out the count of B, so if you see, this A will come over here, which is nothing but A1. These two A1 will also come over here. These two A1 will also come over here. Right? So finally, I should get something like this. A comma 1. A comma 1. A comma 1, and finally those two. I'm not writing it in the interest of like just typing. Okay, so you will get those elements. When we talk about B, right, when we talk about B, this B will come over here. These two B's will also come over here, and similarly these two B's will also come over here. Right? So when I'm talking about this, so the data would look like this: B comma 1, B comma 1, and B comma 1, and finally like dot dot dot. And finally what will happen is with some associative and commutative function, group by key, it will do a calculation, and finally I will get an output that a comma, what is the count? 1 3 5, a comma 5, okay, and b comma 5. I'm getting this computation. Now if you try to understand, or if you try to think, or if you try to see the computation which I am trying to apply, that computation is available in multiple partitioned RDD. It can be available in one, or it can be available in many. So the data is getting shuffled from this parent RDD, from this parent RDD, from this parent RDD, and that's why this is termed as white transformation, because it shuffles the data over the network. Are we able to understand the definition of white transformation?
Yes.
Yes?
Yeah.
Cool.
Yes, sir.
Thank you so much. If we are able to understand, let's write small code. SC dot parallelize. Okay. SC dot parallelize. And then what I will try to do, same example which I was trying to show you, but again I need to have a key value pair. So let me copy this. So key value pair, let's say key value pair, key value pair, key value pair, and last one. That is sufficient. Okay. So we'll write, let's say b comma 1. Let's say b comma 1. Let's say a comma 1, a comma 1, and let's say a comma 1, and let's say a comma 1, and finally let's again take a comma 1. No issues. Or let's change this, b comma, whatever. It's your call how you prepare your data. Based on that you will get the result. Okay. Simply what I need to do is I'll need to create a new identifier, and I just need to say x dot group by key. Nothing else. Simply I just need to copy this, come over here, clear off the screen, paste this. Name b is not defined. Okay, the issue is, as it's a character, I need to enclose that in a string. So that's where your IDE will help you to write your code very efficiently and very quickly. So maybe like you don't try to practice in REPL mode. You can directly practice in your IDE, which I have shown, either in Jupyter or PyCharm. But again, there is no restrictions. You can practice it over here also. Now if I try to say print result of collect, okay, it is giving me what? It is giving me what? Hello? I do not understand, like when I get see, we are getting B over here and A over. We are able to get the key, but the value is in the form of iterable object. Can you see this object? This is the iterable object. Now how to get the result? Okay, let's write a small loop. We can write a small loop, right? Yes, no?
Yeah.
Okay, so I'm just
Yes.
trying something I'm trying to write. Okay, so let's say for j in, I'm trying to write result dot collect. Okay, 1 2 3 4. Okay, so what will happen? This entire row will come in j. Are we able to understand that, right? Correct?
Yes.
So again I will iterate. I will take one more loop for I in. From this j, I want this iterable object, right? Correct? So what I will write? I will j of 1. Right? 1
Yes.
2 3 4. 1 2 3 4. Okay? And simply what I will say print I. Okay, so why we are getting 1?
Because everything is repeated once. That is one one
It is
one
B
one.
of 1.
Correct. Right. Yeah. So I'll write in another form. So hopefully you should be able to get this. So that if you remember the for comprehension,
Yes.
Okay, so we can write the core comprehension also. How I'll write? For j in result dot collect. Okay, so ठीक है, so मेरा for j in result dot collect हो गया. Then I will try to make a list, and that list will contain j of 0. I'm trying to get my key and as also my value at the same place. So I'm just trying to write some syntax, and list of j of 1. Okay, and I think that will get closed. Finally it should get closed over here. Yeah, looks good. So if you see, what I have done is I have applied a group by key. Okay, so based on the key I am trying to find out my values. So I was able to iterate because it was everything one. So with the for loop I was getting the same, I was getting the values, but I wanted to find like for a particular key what are the values. So I've just written a small thing. So for A I have these values, for B I have these values. So what it is happening over here is the data is being taken from multiple partitions. Are we able to understand? Yes, no?
Yes.
Yes.
I think we should stop here because there are more transformations and actions which are came, and I think it will go till 12 o'clock and I don't want to consume your time. So maybe like next Saturday we'll try to finish this remaining transformation and actions, and then we'll quickly jump to the use case. Is that fine, or should I continue?
Then we'll stop your side.
Huh?
Next Saturday.
Yeah. So I